science factory, and my eye makeup is crazy today, and I love it. Today is the first part of a two-part video I'm doing that revolves around a very particular type of chemistry, and that type of chemistry is called combustion. This is combustion. It's fire. As a result of us using fire, every experiment I'm going to be doing in part 1 and part 2 requires adult supervision. Do not play with fire unless you have an adult with you. And even if you have the adult with you, sometimes you should let the adult do the fire instead of you, just for safety reasons. The basis of what we're doing is completely age appropriate for younger kids, but I will be getting into some deeper chemistry because, for one thing, I think it's cool. I think it's fun. For safety reasons, my long hair is tied back in a ponytail. I will also be wearing my old goggles. Again, we're playing with fire, adult supervision. Let's play with fire. All right, so we're playing with fire. We're playing with combustion chemistry. So let's start off with a very simple experiment. What you need is a plate. You need some water. I'm gonna just pour some water onto the plate. Whenever you're playing with fire, it's a good idea to have like a picture of water nearby. So in case something goes awry, in case something goes crazy and you didn't want that to happen, you can just dump water on it to fix it. Water will snuff out fire. I just added some food coloring so the water is a little more visible. All right, super simple experiment. All you need is water, a plate. You'll need a candle. Doesn't matter what kind of candle. I'm using these because these are the kind of candles I had available. You also need some kind of a container. So I'm gonna stick the candle on the plate in the midst of the water. I'm gonna light said candle. Candle is now lit, as you can see. So I'm gonna place the jar on top of the candle, and I want you to watch to see what happens. Ooh, that makes a sound. All right, I think okay, that shows up very nicely. You can see what happened. There's now water inside the jar. The candle's fire went out. When the fire went out, the water inside got sucked up into the jar. And now when I do this, it all comes out. Let's do it again. Let's do it again just in case it wasn't a fluke. In science, nobody cares if you can do something once. Nobody cares if you can do something twice. What really matters is being able to do it 3 times, and that's called reproducibility. Has to do with precision versus accuracy. There it goes. One more time for sake of what you just said, reproducibility. In general, if you can do it 3 times, it's probably a thing. Chemicals do not lie. And there we go. Let's go over to the whiteboard and do some chemistry now. Welcome to the whiteboard. So, even though it didn't seem like we were doing very much, we were actually performing essentially combustion. There are a multitude of different types of reactions. We are working with a combustion reaction with combustion reactions. Very, 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 very simple combustion reactions, mind you. In order to understand combustion, however, there's something before it, and that's the fire triangle. So the fire triangle looks to be very simple. You already know it. You just don't think you know it, but you do know it. Usually the first thing I get from kids is fuel. You need something to burn in order for fire to happen. It needs food. It needs fuel. Just like we need food in order to function, fire needs fuel. The next two sometimes are a little harder to figure out, The next thing you need is, I'm gonna spell this wrong, is an ignition source, or a spark, or heat. Any of that is acceptable to say. Basically, you need something that will start everything off. Friction is often an ignition source. Honestly, when you're using a match, it lights from friction. Friction is a physical force of two things rubbing together. And the last one I think some people are like, oh really? I get air sometimes from kids, and I'm like, well, not quite. You need oxygen, or oxygen as I call it all the time, or O2. In order for fire to happen, you need the fire triangle. You need fuel. You need an ignition source, a spark, heat. And you need oxygen. Without any of these, a fire will not happen. So, in this reaction, we had the candle. There's its wick. And there's the fire. And the candle was burning, and we had water. Then we put a jar over top the candle. And then, the water went in while the fire went out. When we put the jar on top of the candle's heat, because it did give off heat, had nowhere to go. It couldn't go up into the air like it usually has. So instead, all of the heat was just in the jar. So this means that the jar was now hot. The water outside of the jar, well, for sake of argument, let's say the water outside the jar is actually cold. It was room temperature, but relative to what's inside the jar, it was cold. So the water outside was cold. The air pressure inside the jar was hot, and the air pressure outside the jar was cold.
2 hours later.
Pressure and temperature are directly proportional. Meaning, if the temperature increases, then the pressure is going to increase. What happened was the pressure inside the jar increased, and thus it was able to pull in all of the water because it had higher pressure. Another important thing that happened in this was that the fire went out. Why did the fire go out? The candle itself was fuel. We know we had an ignition source, that was the lighter. But the fire went out when we put the jar on it. Why? So I've cleared the water. I'm now going to do the same experiment, but without using water. So once again, we're going to light this. Now I'm going to take the jar. It's out. So the fire triangle your fire needs fuel in order to burn, your fire needs an ignition source in order to burn, and your fire needs oxygen in order to burn. When you do this, when you're just sticking the jar over top the candle that it's lit, the candle will dwindle and then go out. This is because you're taking away the oxygen. The fire is going to continue to eat all of the oxygen that is in that jar. But once all that oxygen is gone, the fire can't live anymore and it will go out. Bottom line of part 1 of our combustion video is that fire needs fuel, oxygen, and an ignition source in order to happen. That is the fire triangle. and air pressure is not an isolated type of science. It goes in plays with other ones, especially this one, combustion. I hope you learned something. I hope you had fun, and I will see you in part 2.